This is the part 4 of the Bhutan rice mapping tutorial series, and in this part we'll be talking about the preparing and exporting of the indices. So the learning objective for this module is preparing and exporting the indices that we need for the subsequent sampling process. And in this module we'll look at how we can export both optical and radar indices. So the script that we'll use in this tutorial is one export_indices.js. This script pre-process Landsat 7, Landsat 8 and Sentinel-2. The pre-processing includes the scaling, removing of the clouds and the shadow using the QA max band. This script also merges Landsat 7 and Landsat 8 and gives you the maximum spatial extent by that are provided by the individual sensor. And this script also then prepares the Landsat based indices, Sentinel-2 based indices, Landsat 8 top of atmosphere tassel cap indices, and Sentinel-1 based indices. And then finally this script will help you export the final composite image and associate indices with the sensors. As others, you'll look for the input needed block to change the parameters needed. So let's go and look at the code itself. For this module we'll be using one export indices. If you click that and run it, let me minimize this. On your console you will be able to see the Landsat 7, Landsat 8, Sentinel-2 top of atmosphere indices and Sentinel-1 images here. So let's see what's going on in the code. So we have our base module that's imported. We also see we have Landsat 8, Landsat 7, Sentinel-2, and we're using Landsat 8 top of atmosphere for the tassel cap indices. And since we're interested in the months from May to October, we'll provide this month list over here, and here goes our year list. We're looking at 2020, and then we have the export path that we need to take care of. So we see that as before, we need to change our export path. So our export path would be inside here, so we can go and click on that icon and you can get the name. Remember the asset is also associated with that path, so after that we should be able to create the image collection. So let's go ahead and just have the image collection as composite_2020. So we're gonna go and create our image collection there, and we're gonna name it as collection_2020. So now we have the correct collections here. So these are the composite collections, and probably have to rename it as a composite instead of the other name. And you saw in the previous video that we have been exporting some of the images, and some of those ascending and descending has been exported. It will take some time to export all the images. As a result, we've already prepared the ascending and descending, and these are the export path that can be used for this exercise. And then as before, it will export the list of dates for that time period. So if you go ahead and print, you'll see the list of dates hit run. So here's your list of dates, which has the start and the end date for each of the month, and you'll see where we utilize that later. So here's the Landsat 8 processing. For the Landsat 8, we're taking the Landsat 8 images within that month. So remember, before for Sentinel-1 we're only using 1 month. Now we're using the entire month, so it will give all the images that are inside the months list for that particular year. And so we select the required useful images, and then you're just renaming over here. Similar things for the Sentinel Landsat 7, sorry. You get all your images for that growing season. You select the required band, and then you rename those bands. Then as I said, that we're merging Landsat 7 and Landsat 8. So the way we're merging Landsat 7 and Landsat 8 is by calling this function get Landsat 7 Landsat 8 reduced image. We provide list of dates, Landsat 8 collection, 7 collection, and this will give you the image collection for the months wise basis. So let's go ahead and look this file, actually this function. So this function is inside the routine file, and this function is called get Landsat 7 Landsat 8. And if you look here, it applies the scale factor, and then it marks the cloudy and the shadow pixel. The way it's marks is using this function called marks Landsat 7 Landsat 8, which uses the QA pixel in order to do all the masking. So it uses the information provided in the image itself to do the masking, and then it iterates over each of the dates, get the mosaic per month from both Landsat 7 and Landsat 8. You could also do a median composite, but then your spatial extent are limited, but because the median composite would only work for pixels that have non-maxed pixels. So we're using mosaic in this case. Now if we go back and look here, so that's where we are merging. We get the collection per month, and then we're taking a median of that collection. So, and these are the same stuff that we did. We're just selecting the useful bands and then converting them to a floating point integer, and then in this line 144, that is where we calculate the Landsat 7 and Landsat 8 indices. So this function is inside the indices module. So let's go and look at the indices module and search for Landsat 7 Landsat 8 indices. So it takes your image collection or image. If it's an image, it just takes the image. If it's an image collection, it will make a median. Remember, we are passing the median composite here, so we are receiving an image and not an image collection. And then it calculates NDVI, NDWI, MNDWI, SAVI. You can add as many other indices that you want to calculate, and at the end it just returns all those indices back to the calling function. So if we go back and look, so now we have our Landsat indices. We have printed those over here. You can also see the Landsat image. These were the collection before. The image has now altogether 6 bands. It does also have the QA marks because that is removed in the next line. But if you look at the Landsat indices, you'll see all the indices that we prepared from the Landsat indices function. So and then on the next lines we add them to the map. as well as export them. So if you go to your tags tab, you will see all the tags that are unsubmitted, which are ready to be submitted. So you can see Landsat Composite 2020 and Landsat Composite Indices 2020. Now let's repeat the same process for the Sentinel-2. For Sentinel-2, again getting all the images in our months list, and then we apply the masking for the Sentinel-2 collection as well through our routine module. So let's go ahead and look at this function. So this function uses QA60, which gets rid of the cloud and the cirrus cloud from the images. So this process is done for Sentinel-2, and then we do a median composite and again calculate the Sentinel-2 indices similar to the Landsat indices. And here we're renaming it so it's much easier to read. And in the next steps, we also calculated the Sentinel-2 indices. So these are also printed over here, and you can go and look at the indices that are available for Sentinel-2. Okay, so now we'll do similar for Tessel cap. For the Tessel cap, we'll use a top of atmosphere Landsat 8 images, and then we are renaming each of the images, and we calculate the Landsat 8 top of atmosphere Tessel cap indices function that is inside the indices module. So if we go and look at that particular function, the reason we're using Landsat 8 of top of atmosphere is that the Tessel cap is an dimensionality reduction process, and it gives you all these 6 dimensions referred to as brightness, greenness, weightness, 4th, 5th, and 6th. Weightness, as you've guessed, gives you the weightness of a particular pixel. Similarly, the greenness and brightness gives you the similar kind of application. The coefficients used here are specifically tied to the Landsat 8 top of atmosphere. If you want to use a surface reflectance, you might have to adjust your parameters accordingly. And then we calculate all these indices over here and return them back. So if you go back and look, that is where your Tessel cap indices are calculated, and it's printed over here. Has 6 bands: brightness, greenness, weightness, 4th, 5th, and 6th. Adds to the image, to the map over here, and then also export it. So that's where it's exported. So now let's go at the Sentinel-1. We exported Sentinel-1 composite per month wise in our previous exercise. So we'll make use of that over here. So we're calling for that particular year, we're calling the Sentinel-1 descending, our Sentinel-1 descending. Remember, we're using the cloud assets that's already set up out there. In reality, you'll create everything and then refer to that path. And then it also calculates Sentinel-1 indices. So if you go again inside the indices module and search for calculate Sentinel-1 indices, you'll see it has VV, VH, the ratio, and the normalized difference ratio between VV and VH, similar to an NDVI is a normalized ratio between NIR and red. So that's done for ascending as well as descending, and then are exported over here. So so ideally you'll just change this, make sure your paths are correct, your ascending and descending paths are correct, and then run it. So when you run it, you'll also have to make sure your paths are correct. So our export path is actually, we changed that, and let's go back and change it again. It's EESS Bhutan, and then the composite underscore year. So let's run this again, and then when you run it, your tags should start appearing here. So let's go ahead and run each of them. Okay, making sure that our names are correct and it's in the correct path. A handy trick is if you hold a control in your keyboard, that dialog won't appear, so I'm doing the same trick here. Okay, so now we're preparing all our composite images that goes into our next module, and we'll see you in the next module.